Problem number 2. A standard checkerboard has 64 squares alternating black and red on an 8 by 8 grid. How many of the 1,296 rectangles on the checkerboard contain more than one red square? Alright, more than one red square, that's the question. And when I see more than one, or at least one, or at least, or something like that, I guess in this case it'd be at least two would be equivalent to more than one. I think complementary counting, okay? So let's use complementary counting for this. Complementary counting. And complementary counting just means counting the thing you don't want and then subtracting it from the whole. And the complement, in this case, of what we do want, so we do want the number of rectangles that contain more than one red square. So the complement of that would be one or less, one or fewer, one or fewer red square. Okay, which just essentially means either one red square or 0 red squares. And that's a lot easier to count because there's a lot fewer rectangles that contain either 1 or 0 red squares than there are that contain more than one red square. Okay, so this is just easier to count. And we know the whole, actually, we're given the whole. There are 1,296. Now, you may be wondering how they got that. There's a little bit of a trick to that. This isn't really part of the problem, but you can think of this grid as being, there's lines that divide this grid. So essentially, you've got 9 lines up and down, and 9 lines horizontal here that make up this grid. So the way that we get, oops, where'd my pen go? There we go. The way that we get 1,296 is by, if we choose any 2 of the vertical lines and any 2 of the horizontal lines, we'll automatically get a rectangle. Okay, so we can actually calculate it by doing 9 choose 2 times 9 choose 2. Okay, and that's equal to 9 times 8 over 2 times 9 times 8 over 2. We can make that a 4. So it ends up being just 36 times 36, which is 1,296. Okay? Now that's how they get the 1,296. Now that's not part of the problem. That's already given, but that is the whole. That's the total number of rectangles that can be formed from 1 by 1 rectangles, which is really a square, but it's still a rectangle, to 2 by 1s, to 3 by 5s, all the way up to the big 8 by 8. Okay? So this is the number of rectangles, and if we count the ones that have one or fewer red squares and subtract it from this, then we'll get what we're looking for, which is the ones that have more than one red square. Alright, so let's first of all look at 0 red squares. Red squares. Alright, those are just the black squares, right? So we know we have 1, 2, 3, 4 black squares across and 1, 2, 3, 4 black squares down. So we have a total of, what do we got? No, wait a minute, I gotta think think about this better. Alright, so we have 4 in each, we have 4 black squares in each row, and we have 8 rows. Okay, so we have 32 black squares. Alright, so those are the rectangles that can be formed that don't have any red squares in them. Okay, now other than that, we can have one red square, and there's a number of ways that we can get one red square. Right? I mean, we could just take the single red squares, and that would be another 32 red squares. Okay. Or, let me scroll down here. We can take squares that look like, let's see, we can take squares that look like this, that are just 1 by 2. Okay. So you can see if we took a rectangle that looked like that, where it's got one black and one red, then how many are we going to have across each row? We're going to have, there's 1, there's 2, there's 3, there's 4, there's 5. I don't know if I got a very good color here. What have we got? 5, 6, and 7, right? So we'll end up having 7. So if we, maybe I should just draw this. So if we have the this sort of thing. So we have these kind of horizontal red-black combinations, or they could be black-red combinations. So we'll have 7 of those in each row times 8 rows. Okay, and we'll also have, if we go down the columns, we'll have the same thing for the columns. You know, so we'll have one that looks like this. There's 1, 2, 3, 4, 5, 6, and 7. Okay, so we haven't done the columns too, so we have to add those in. So that's again 7 of these rectangles times 8 columns. All right, so that's just 56 plus 56, which is 112. All right, so we'll have 112 that have one red square where it's a 1 by 2 rectangle, and that'll be all the 1 by 2s, including the horizontal ones and the vertical ones. All right, so let's erase all this garbage here, and let's look at another case. So let's see. So we can look at 3 by 1 squares that have 2 black squares. So let's color a couple of these black, and another one black, and a red in the middle. Okay, that'll be another case, another type of rectangle that we can look at that only has one red square. Okay, so let's figure that one out. Alright, so let's see. Here's one. Let me see. I need a different color. Do orange maybe. So here's one. Okay. And you can see this 1 by 3 is going to have 2. That we don't want that one. Here's 2. And here's 3. Okay. So it looks like there's just 3 in each row, and then there'll also be 3 going down for each column as well. All right. So we'll have 3 of those rectangles. Oops, I'm going to switch back to black. It'll be easier to see. 3 of those rectangles for each row, and 3 for each column. Okay, so 24 plus 24, that's 48. And I think that's all we can get. That's all I can see that we can, if we add any more rectangles, we end up having to include another red. And we're looking for the complement, which is 1 or fewer. Okay, so we've added up so we've got the ones that don't have any red squares, which would be just the black squares. We have the 1 by 1s that are red. Okay, so those look like this. All right. And then these are the black ones that are just singles. Okay, so we have 32 black squares, 32 red squares, and then we have 112 of these 2 by 1s and 48 of these 3 by 1s. So So let's add that up. Okay. So there's 10, there's 4, 14. We'll carry the 1 here. Keep losing my pen. All right. So then that's 7, 8. So that's 100 and, let's see. Is that right? 224. Right? So that's what? Make sure I got that right. 6, 7, 11. I should get 224. I'm not adding right here. Oh, I see. I'm messing up. I got my column kind of skewed here, so it's kind of hard to see what I'm doing. All right, so we have 224 of these squares. Now these are the ones with 1 or fewer red squares, right? Which is the complement of what we're looking for. So if we just take that and we subtract it from this 1296, so let's take 224 minus the 1296, we'll get 2701. Okay, so the ones that have at more than one red square are 1072. Okay, because our rectangles that we form either have to have 1 or fewer red squares or more than 1 red squares, right? There's no other possibility. So that's why we call it the complement. They complete each other. Okay, those two cases complete each other. The thing we're looking for and the complement complete each other. So if we subtract the complement from the whole, we get what we're looking for. All right? So that's the whole idea behind complementary counting, and it's easier sometimes to count the complement. It would be kind of a kind of hard work to figure out, to count all of the ones with two all the way up to 32 red squares. Okay, so so counting the complement in this case is easier, and it gives us an answer of 1072.